Okay, we will continue the ventricular system anatomy. Today we will learn about the third ventricle. Okay, if you before starting this video, it will be good if you see the overview of the ventricular system so that you can go in depth in this third ventricle topic. As I mentioned in the previous video, the specific learning objective suggested by the CBME of the National Medical Council of India is that you need to demonstrate and describe the parts and boundaries and features of the third, fourth and lateral ventricle. So, third ventricle is pretty important for this. Now, where is third ventricle located? This is a picture in an atlas of anatomy in which you can see that the third ventricle is located here. If you have remember the video of the overview of the ventricular system, this part is the third ventricle. Okay. Third ventricle, as I said in the previous video, it is a midline cavity. Unlike the lateral ventricle, which are paired cavities, this is a single midline cavity and it is located within the diencephalon. It is the cavity of the diencephalon. And one way to remember what are the structures of the diencephalon is that you can remember they are the structures with the name thalamus. So, that includes the thalamus, okay, thalamus, the hypothalamus, and the epithalamus. Okay, these are the three thalamus named structures that you can remember that are included under what you call as the diencephalon. So, the third ventricle is the cavity of the diencephalon. So, they will be related to all these structures which has the name thalamus. That includes the proper thalamus, which is called as the dorsal thalamus, the hypothalamus as well as the epithalamic structures. So, let us have a look at that anatomy first and then have a look at the features of the third ventricle, including the third ventricular recesses. Okay. So, here if you look at this anatomy, this is a midline sagittal section of the brain and a more closer look, and you can see that this is the midbrain, this is the pons, and this is the medulla, and this is the cerebellum, right. The midbrain cavity is called the aqueduct. The aqueduct has an opening into the third ventricle. Okay, there is an opening there, and from there you can see a rough line that you can draw till the foramen of Monro. Okay, this will be a faint line which you can actually see in an anatomy specimen. If you take a midline sagittal section, a fresh section if you take, you can see this faint line. That line is important because below that line you have what is called as the hypothalamus, and above that line you have what is called as the thalamus, also called as the dorsal thalamus, and this line is called as the hypothalamic sulcus. Technically you have two very faint hypothalamic sulcus on both sides when you look through the third ventricle. If you cut through the third ventricle in an anatomy specimen and you look laterally, you can see this very faint line connecting the aqueduct of Sylvius onto the foramen of Monro. That is called the hypothalamic sulcus. So, this slit shaped cavity between these two structures, the thalami on both sides and the hypothalami on both sides, that is called the third ventricle. Okay. So, the third ventricle location is like this, and on the dorsal aspect, on the posterior aspect of the thalamus, if you look at that picture, you can see this structure which looks almost like a pine cone. That is why this structure is called as the pineal gland. Okay, pineal gland. So, pineal gland is located on the dorsal aspect of the thalamus, and pineal gland has two lamina through which it is connected. Okay, this is called the inferior lamina and this is called the superior lamina, on which you have the posterior commissure and the anterior commissure. I have annotated all the structures there. Okay, all the structures are kind of necessary when you understand this midline sagittal section anatomy. Okay, so that the pineal gland along with the habenullar nuclei, the posterior commissure, this region is what you called as the epithalamus. So, I told you earlier that anything with the name thalamus is part of the diencephalon, and diencephalon contains the third ventricular cavity. So, you can see how the third ventricular cavity, what you see here is the third ventricular cavity is related to the hypothalamus below, the thalamus above, and posteriorly the epithalamic structures. So, all these things are very clear in this image. Right. With that, I'll just mention about a couple of boundaries that you see in the third ventricle, which are very important, because in front, this is the third ventricle, as I said before, this is the hypothalamus. If you look in front, this structure that you see is the anterior commissure, that is the anterior commissure. This large structure that you see is the largest commissure that you know, that is called the corpus callosum. Okay, but that is not related to the third ventricle, but the anterior commissure is related to the third ventricle. Okay, you are seeing a section of the anterior commissure. Now below here, what you are seeing here, that is the optic chiasma. Okay, that structure is called the optic chiasma, and between the anterior commissure and the optic chiasma, you can see this structure that is called the lamina terminalis. Okay, I am writing it in a short form, lamina terminalis. So between the anterior commissure above and the optic chiasma below, you can see a film like structure that is called the lamina terminalis. Okay, so lamina terminalis will be the anterior boundary of the third ventricle, right? Because this is anterior, you can see that this is anterior and this is posterior. So the anterior boundary is the lamina terminalis, and inferiorly you can see the optic chiasma here, and below the optic chiasma, you know, this gland is the master gland that you call as the pituitary gland. Pituitary gland is located just below the optic chiasma, and that is a very, very important relation. Okay, a very large pituitary tumor, that is the reason why a very large pituitary tumor can extend above and compress the optic chiasma, causing field defects to the vision. Visual field defects can be a presentation of a large unattended pituitary tumor. That relation is therefore very important. So you can see the pituitary gland there, and into the pituitary, this structure is called the infundibulum. Okay, that the stalk of the pituitary opens into the infundibulum. So that region is called infundibulum, and you can see here the third ventricle has two pockets. Okay, one pocket that lies just above, I'll use another color to make that clear. One pocket that is lying just above the optic chiasma, and another pocket that is descending onto the pituitary into the infundibulum. Okay, these two are pockets of the third ventricle. Pockets you call as recesses. Okay, so that recess is called the suprachiasmatic recess or the supraoptic recess, and this is called the infundibular recess. So these two recesses you see on the anterior aspect. So you understood the anterior and inferior relations. All those relations are very important, and the recesses that are related there. Okay, so all this anatomy is very important. Now if you look at the posterior aspect, you can see that into the pineal there is a recess that is extending. Can you see that? Okay, that recess is called the pineal recess, and above that you can see another recess going like this. Okay, a little more fainter recess, a pocket that is called the suprapineal recess. And what are the communications of the third ventricle? One communication is through here into the lateral ventricle, which is located laterally, that is called the interventricular foramen or the foramen of Monro, and another communication is through this is the aqueduct of Sylvius, and that is communicating the third ventricle onto the fourth ventricle. Okay, this completes the basic anatomy overview of the third ventricle. We mentioned about the anterior and inferior relations, the recesses present anteriorly, inferiorly, and also the recesses present posteriorly with the relations present posteriorly, and also the communications of the third ventricle. Laterally you are seeing the foramen of Monro or the interventricular foramen, and below you are seeing the aqueduct of Sylvius. Okay. One more relation that is not very clear in this picture is this. This is the tela choroidea of the third ventricle. What I am showing here as green colored structure, that is the tela choroidea of the third ventricle. Tela choroidea is almost like a double layered sheet that extends in the roof of the third ventricle, and on that roof you have the choroid plexus of the third ventricle. Okay, that is called the tela choroidea. So that is a superior relation. So with that we kind of covered the boundaries and the relations, and we mentioned the recesses. So let's go to the name of the recesses once again. As I said before, the third ventricle is located within the diencephalon. They are located between the thalami and the hypothalami, because you have the hypothalamic sulcus here. So this is the thalamus and this is the hypothalamus, and we mentioned about the recesses. So let us have a look at the recesses alone. This is kind of a ventricular cast. Okay, what you are seeing is a ventricular cast. 3D rendition of a ventricular cast. In that you are seeing the recesses, the third ventricle over here, and the recesses of the third ventricle. This will be the supraoptic recess, because here you will have the optic chiasma. This will be the infundibular recess, because there it is extending into the pituitary, that will be the infundibular recess, and posteriorly you are seeing the pineal recess. Okay, that is the pineal recess, and this is called the suprapineal recess. So these are the recesses of the third ventricle. I mentioned in the first video of the ventricular system overview that you can see, sometimes you can see a large hole in the third ventricle, a cast. This is a cast because you imagine the third ventricle is filled with something and you are taking an impression of that. Okay, then you will see a large hole in it. What is that? You know that the third ventricle is a slit shaped cavity located between the two thalami. Now, the two thalami are so close together in the midline, and they are so close together that sometimes they can kiss each other. Okay, that's what we call as the interthalamic connexus or the interthalamic adhesion. So you imagine you have two egg shaped thalami, and between that you have a slit shaped lateral ventricle, and imagine the two thalami are adhering together, forming an interthalamic bridge, an interthalamic connexus. Then that third ventricle will have a hole inside it. That is what you are seeing here. So when you see a hole like this in a ventricular imaging, that means that that is the interthalamic adhesion or the interthalamic connexus, also called as the massa intermedia. This is also called as massa intermedia. So if you see that, that means that is an interthalamic connexus. Okay. Now we will see these structures in a 3D rendition in the AnaView tool. Okay, now you are seeing the AnaView tool. As I mentioned in the previous video, in this tool you are seeing a 3D viewport in the center, and on the right side of the screen you are seeing the three canonical planes. These canonical planes, you can move your mouse there and you can scroll it into front or back to see the different structures. As you can see here, you can see the ventricular cavity. My mouse cursor is now pointing on the ventricular cavity. Okay, so you can move like that. So let us have a look at the third ventricle that we mentioned just now. I am zooming in more closely, and you can see the third ventricle is located in the midline. To understand that more, I am going to move this sagittal plane more laterally, and you can see how far the two lateral ventricles are. See how the two lateral ventricles are located very far, and how they are communicating through the interventricular foramen. This is the two interventricular foramen located very close to each other to a midline slit shaped third ventricle. See how small the third ventricle is. This understanding is not very clear unless you rotate this ventricle and understand how spatial anatomy is very important. In a lateral view, you may feel that the third ventricle is so large, but the third ventricle is actually a slit shaped cavity located between the two thalami. Okay, this is the midline front view of the third ventricle that you are seeing. In an AP view, an anterior posterior view, you are seeing the midline, a slit shaped midline cavity that you are seeing here. Okay. Now I am going into the lateral view again, and I want you to appreciate the communications of the third ventricle to the lateral ventricle through the interventricular foramen that you are seeing there. Okay, that structure now where my cursor is, that is the interventricular foramen. That is, okay, again the third ventricle is communicating with the fourth ventricle located below through the tube like a small channel. That channel is called the aqueduct of Sylvius, or the cerebral aqueduct of Sylvius. Okay, these two are the communications of the third ventricle to the other parts of the ventricle, to the lateral ventricle as well as to the fourth ventricle. Okay, now I'll bring back the sagittal plane to the almost the midline to kind of make us understand the recesses more clearly. See, look at this. You can learn a little bit on the 3D graphic as well as a little bit on that MRI. If you look at this MR image, you can see the posterior pituitary here. This is the anterior pituitary. This is the optic chiasma. Okay, that is the optic chiasma. See, above the optic chiasma you are seeing a beak shaped recess. Okay, that is the recess, the pocket of the third ventricle that is located just above the optic chiasma. What will you name that? That is called the supraoptic recess. Supraoptic recess. This will be the location of the anterior commissure. So between the anterior commissure and the supraoptic recess, you have the sheet like lamina terminalis. Okay, lamina termini. These are the anterior relations, very important anterior relations of the third ventricle. So, you can enter into the third ventricle if you rupture the lamina terminalis. This is a very important relation. Now, behind and below this supraoptic recess, you can see another pocket, a more narrow pocket that is extending into the pituitary stalk. See, you can very clearly see how the pituitary stalk is located. Like I can play with this sagittal image laterally and move it sideways, and you can see how the this recess, this cavity is going through this recess into the pituitary. This is called the infundibular recess. So, these two are the recesses that you see in front, the supraoptic and the infundibular recess. Now, let us look at the posterior aspect. This structure is the pineal gland. I will just move it sideways to show the pineal gland very clearly. Okay, that is a pineal. Into the pineal you can see the pineal recess, that is the pineal recess, and above that you can see the suprapineal recess. Suprapineal recess is very close to the habenular trigone, where you have the habenular recesses there, the habenular commissure is present over there. So, that is that region, the suprapineal recess. Also some others call it as a habenular recess. That recess is located just above it. Okay, these are the recesses of the third ventricle. Now, you can see this large hole in this third ventricle. I mentioned about that hole earlier. What was that hole? That hole is the thalami. The two thalami are very close to each other, forming a large massa intermedia in this scan image, and that is the reason for that hole being created. Let us have a look at this axial section to make that clear. Okay, whether we can see that. Let us move this axial plane up to that point. Okay, you are now seeing the third ventricle. Okay, this is, you are seeing the sections of the third ventricle over here, and I am moving it upwards, and can you see over here, this is the third ventricular cavity. The black colored what you see here, that is the third ventricular cavity, and you can see this is the thalamus. Okay, on one side this is the thalamus of the right side, this is the thalamus of the left side. Between that two you can see the two thalami are adhering together, creating the massa intermedia. So, that massa intermedia, if you move it, you can see that is enormous. Okay, pretty large. It is going through different sections, and that massa intermedia is the one that is creating this hole in the third ventricle. Okay. So, with that we have completed the 3D anatomy of the third ventricle, its boundaries, its important relations, as well as its recesses. Okay. Third ventricle is a usually asked topic in theory examinations and MBBS neuroanatomy examinations. So, third ventricle is very important. So, this gives you not only the theoretical aspect, but also a very practical spatial understanding of the third ventricle.